Okay, it is a couple minutes past the start of the hour. We've only got 30 minutes, so I'm going to go ahead and get things going. Welcome, everyone. Thank you for joining. My name is Carl. With me is Sergio, and we are with a company called Imply. We were founded in 2015 by the original creators of Apache Druid, which is an open source analytics database, just like ClickHouse. So what you're seeing here today is a comparison of two open source analytics databases. And of course, Sergio and I are a bit biased since we work on the Druid side, but hopefully we'll give you a good factual analysis of these two databases and why we think you should consider using Apache Druid for your next project, or maybe even as a replacement for ClickHouse if you're looking for something that is going to grow with you a little bit better over the years. So, why are we even talking about Druid versus ClickHouse to begin with? Well, it's because real-time analytics, or RTA, as I have in the title there, real-time analytics is not something that a legacy database or a cloud data warehouse can really solve. If they could, then you would all be using Oracle or Sales or Snowflake, and you wouldn't need to talk to us about Druid or ClickHouse. But because we're here, that's indicating that there's challenges with real-time analytics, and you need a database that's built for it. And these are the three challenges that you see here: interactive analytics at any scale, high concurrency at the best value, and insights on both historical and real-time, or both batch and streaming data. I think most people probably recognize that if you're going to do sub-second queries on a large amount of data, that's not something a traditional database or a cloud data warehouse can really do. I mean, Snowflake, if you start scaling them up, you start getting a lot of concurrency, it gets really expensive. And that's just because of the way they're designed and the priorities that they place more on flexibility and cost control rather than on serving analytics at scale. So this is why we are in business and why you're considering whether Druid or ClickHouse is the right choice for you. Look at some of these customers and what they've done with Druid. I particularly like the Target story. A petabyte of data, 3,500 plus data sources on Druid, 70,000 daily average users, 50 queries per second, all of them on average sub-second in response. That is, again, speaks to the need about why, if you're going to do an analytics application, you need a database that's built for it. So what is it in particular about Druid that that customers like, and why are they adopting it, and what is kind of my plan here for comparing the two databases? I'm going to compare them along these three lines here. How do you get sub-second at scale? How do you do true stream ingestion? And how can you get nonstop reliability? So we're going to compare Druid and ClickHouse on these three levels here. And, you know, we might as well take a moment to think for a second here. What would ClickHouse say about us at Druid? What would they criticize us for? Or what would they say if they saw this slide here? Well, I can tell you because I know. They would look at that architecture diagram on the left and they would say, wow, there seems to be a lot of things there. You've got a separate deep storage layer below. You've got three different kinds of nodes: master nodes, query nodes, and data nodes. And I think ClickHouse would say, hey, we don't have that separate deep storage layer, so it's a little simpler. We really only have one node type, query node. So I think they would say, this Druid thing seems kind of complicated. And it's true that we do have more components in our architecture than ClickHouse does. We've got more stuff, more stuff there. And my job in the next 15 minutes or so before we handed it over to Sergio for a demo, my job is to explain, hopefully convince, why that is a good thing and why you're going to want those things in the architecture rather than having a simpler architecture. The key thing, I believe, is those two important words towards the top of the slide here: sub-second at scale and our unique architecture. Let's be honest, if you have a small amount of data and a handful of users, well, you can survive on just about any database for that. There's no magic in doing that. But I don't know many developers or architects who build an analytics application and then sit back and say to themselves, great, we're done. Now I hope nobody uses it. I hope it never grows. I hope all that work was for nothing. No, of course you want your application to grow. So the at scale part is really, I think, the theme that you're going to see in this presentation is that if you got a small enough scale, any database will do. But when you begin to grow, that is when you're going to want this kind of architecture in place to assure that you will continue that high performance even with growth. So let's talk about the architecture, because I think it's really where we begin to see the differentiation between ClickHouse and Druid. On the left is a review of the two major kinds of architecture for an analytics database: shared nothing and separate storage and compute. So shared nothing, you'll see here, again, this is a very simplified diagram, but you'll see here I've got a picture of a 4-node cluster, and each node has its own storage and its own compute resources. This is a classic architectural design that's been around for decades. It's not sharing anything. Every node has all the resources it needs. And this is a very good choice of architecture for query performance. So along comes Snowflake, and they have a different idea, and they say, let's separate the compute and the storage resources. Now, there's some good reasons for this. One is, when you do that, you can easily add compute resources, scale up, scale down. It's not a problem. You do that here in a shared nothing architecture, it's a big problem. If I want to add a node here, add node number 5, I've got to rebalance the entire cluster, which unfortunately for almost every database that I know of that's using shared nothing, that is a lengthy and manual process. And that would include ClickHouse. Don't have that problem down here. I can add resources whenever I want. The problem with this separate storage and compute issue here is this connection between the two slows everything down. And so your success performance-wise depends on how good this database is at predicting what you want to do and caching the data so that it's ready to go for a query. So the best case scenario is you're going to get a very slow first query. Now, Druid is, we call it a shapeshifter because the Druid character in a lot of fantasy role-playing games was a shapeshifter. One of the reasons it's called that is because of this hybrid architecture you see on the right. We do both. We do both a shared nothing and a separate storage and compute. And this is pretty unique. So we have the two layers so that you get the flexibility of adding a node or removing a node whenever you need to, and the cluster simply rebalances automatically. There's no downtime, there's no manual effort like you would have to do on ClickHouse for the same operation. At the same time, to improve query performance, we take the data that is in the deep storage layer and we prefetch it up to that compute layer here so that there is no wasted cycles trying to optimize cache, or there's no cache misses when you are doing a query. You don't have to worry about what your users are going to query next. And we can do this at a lower cost because we have a very efficient storage architecture. It's columnar, it's highly compressed. We have indexes that are automatically built on any string data, and they're right there in the data segments. We use segments and not technically shards like you would get in ClickHouse so that they're easier to manage and move around. They're smaller. They don't have to be balanced across the entire cluster entirely, which is an advantage. So we have found that this approach is actually cheaper than doing a cloud data warehouse. In fact, the customer that was on the previous page, Imply Digital in Germany, they were using a hyperscaler solution for this prior to going to Druid. And they were able to add with Druid 30 times the number of concurrent users, but actually reduce the price of the system 25%. So we think this is where the battle lines are really drawn between us and ClickHouse. Because they are shared nothing. What that means is that anytime you need to grow, you've got a challenge on your hands. You've got a problem on your hands with manual work, with balancing, where you're not going to have that problem with us. I think this is the biggest difference between the two systems. But let's talk about how this architecture impacts some other things as well. For example, resilience. We do have that separate deep storage layer. If you're running on premise, you could just run HDFS, but most of our customers are running that deep storage layer in the cloud, like on Amazon S3 or maybe on Azure. There's a variety of choices you can do there. And we automatically replicate continuously the data from the data nodes to that separate storage layer. So it's always backed up. We also have a replica for each data node as well. This is also something that you can do in ClickHouse. You can create a replica. Well, that protects you against an individual data node going down, but it's not a complete solution. You do need to do a complete backup. And that's something that you don't get with ClickHouse unless you do it. So backups are going to be arbitrary based on the whim of the administrator and when they get around to it. With Druid, it's going to happen automatically. So really, the only thing that's going to take this system down is if you're, say, running on S3 as your deep storage layer, if that whole region of S3 goes down, which happens, on occasion. And I think it happened pretty recently, actually, with the eastern region of S3. That would be the only thing that's going to cause you any downtime at all. Losing a node doesn't cause you downtime because you can see in the center of the screen here, we'll automatically recover from a lost node. If you lose the node and all its replicas, we just simply rebalance. We do the automatic rebalancing, as you see on the right. So if you need to do maintenance, you don't have to shut the system down for that either. So very resilient. Nothing's going to take this down except a very rare situation where you lose an entire region of your cloud storage. And if that's a concern, of course, Amazon and all the others have solutions for that too, with replicating to other regions. If you really need that kind of resilience, it's possible. This is, again, out of the box with Druid. Another advantage, because of our architecture, is with stream analytics. Druid was really built for stream analytics. And there's a couple of things here, 3 things in particular we do that are unique in the analytics business. One is we natively connect to Kafka, Kinesis, and Azure Data Hub. Everybody else, ClickHouse included, is using a connector. So if you go to, say, Kafka's connector page, you won't find us there. We don't need to be there because we natively connect, and that gives us some really unique advantages when it comes to stream analytics. One of them is query on demand. Because we are a truly connected event by event stream processor, you can query these events as soon as they hit the cluster. So they come in, they're stored in memory on the data nodes before they're persisted to storage, and it's in that moment you can query those events right away. Everybody else, ClickHouse included, is actually not doing event by event streaming. They are doing batch mode. ClickHouse recommends at least 1,000 events per batch if you read their documentation. We don't do things in batches here. We are a true stream analytics solution for this. So that gives us query on demand. It also gives us exactly once semantics guaranteed. So what this means, well, there's an illustration there of a common problem that you might get. Maybe Kafka sends you the same message twice because there was a communication error and it never got the acknowledgement. Well, that's going to mean duplicate data. Because we are natively integrated and we're a true event by event processor, we pick that up and we don't allow that to happen. With ClickHouse, for something like this, you're going to need to run a query at the back end to look for duplicates and remove them. Or you're going to have to roll your own solution at the front end of this to guarantee exactly once semantics. I don't think you should have to do either of those things. Your solution should just take this into consideration right away. So this is a big advantage that we have, again, because of the architecture differences. Because we do have more components in our architecture, we are able to do this kind of thing. We're able to scale without bringing the system down for rebalancing. We're able to do these kind of nice features here with query on demand and exactly once, guaranteed. And so this is, I think, one of the key differentiators choosing between Druid and ClickHouse. So how can I wrap all of this up before we send it over to a demo? Well, I put together this table for you here, and it's got some of the key things that you should know about. And again, these are all consequences of the architecture. So yes, it is true that we have more components in our architecture, but this is where you start to see the benefits of doing that. So let's talk overall management at scale. Because of our architecture, we are able to add a node, remove a node goes down, whatever, and you don't have to worry about it. There's no rebalancing, there's no recovery thing you have to initiate. It just happens, okay? So I kind of like to use this analogy of pets versus cattle when I talk about this. Pets are wonderful. We love them, we give them names, we give them special diets, we might even put clothes on them, who knows? We treat them as individuals. But you start getting 5, 6, 10 cats in the house, and it becomes kind of hard to manage. If you're going to have a whole herd of animals, you want an animal that is going to be good at being in a herd. You want cattle where everything is fungible. You can pretty much replace the cattle and it doesn't really matter to the whole herd, right? It's much easier to manage that. So when you look at ClickHouse, because they only have one query, a one node type, and because they have to evenly distribute the data across the cluster, you might think of it this way. Every node in a ClickHouse cluster has essential state on it. And if it goes down, it's fatal. Whereas with Druid, we have master nodes and query nodes that are managing this workload. And so the data nodes just become fungible. Add them, remove them, they go down, whatever, it's not a problem. You don't have to deal with it. This is where having those extra 2 components and having that deep storage layer pays off, is when you start to have big scale, you will want this kind of capability. We talked about stream analytics already, how we're true streaming analytics with exactly once guarantee. We talked about resiliency and how we're automatically replicating to deep storage. We didn't talk yet about these last 2 items, so let me touch on them briefly. But again, this is a consequence of having an architecture that's built for scale, having those extra components. This is where that begins to pay off. If you're a shared, and this, by the way, it's not necessarily a dig at ClickHouse. What I'm talking about are actually problems that you'd have with any shared nothing cluster. It's not just ClickHouse. It would be any other database out there that's using a shared nothing cluster. When it comes to indexing and high cardinality queries, so let's say that you've got a lot of data, but let's say that rather than the typical queries are looking for ranges of things, like show me everything that happened in the first quarter, show me everything that happened in Japan, right? Big ranges of data. But what if your users start asking for very specific amounts of data, small result sets coming from a large amount of data? This is where we really begin to shine in this area as well. In a shared nothing cluster, because everything is distributed evenly and there's no master node to tell you where things are, when you start to get high cardinality queries on a large cluster, it begins to really slow down the cluster because it has to get that data from across the entire cluster. To solve this with ClickHouse, you do something called a subcluster. This is how Yandex, how they run, well, they're the original creators of ClickHouse. This is how they run their clusters. They create subclusters because of this problem. There's a great article out there on Yandex and subclustering if you want to read it. They'll tell you all about how they do it. I don't think you should need to do that. I don't think you should need to do that workaround. But because of our architecture, we're much better at these high cardinality queries. Same thing is true for prioritizing. Everything is equally expensive in ClickHouse because, again, there's no coordinating node. It has to be evenly distributed. So therefore, you have to have everything on the same expensive hardware. What if you wanted to have a system where you have more recent, more valuable data on an in-memory resource, but older, less valuable data on a cheaper but slower resource? That's called tiering. Because of our architecture, we can do that. You can't do that in ClickHouse, again, because they are a shared nothing cluster. So about those extra nodes that we have, those extra node types, the extra storage layer, they do pay off when you get to scale. But in the beginning, if you want to make it easier, I would suggest looking at Druid and running our Polaris product here at Imply. This is a fully managed cloud or database as a service product where we take care of all that complexity for you. You can get a 60-day trial and we'll run the cluster on your behalf, and you can, pay as you go with this. So I would look at Polaris as a way if you want to analyze Druid and see if it's going to be good for you. And speaking of Polaris, let me turn it over to Sergio because he's going to do a little demonstration, bringing some data in from ClickHouse into Polaris, and you can kind of see how all of that is going to look in the real world. So Sergio, I turn it over to you.
I am now unmuted. What I'm going to show you today is a simple example of how to extract some data from ClickHouse, what form to extract it in, and then ingest it into Polaris. Like Carl mentioned, Polaris is something that you can sign up for free. I don't know if we can send the link into the chat. We should do that. But in the meantime, I'll start here at ClickHouse. Right? Let me go to the ClickHouse client and query some data just to show you that we actually have a little bit of data there before we extract it. So there's a sample table that we created with about 300,000 rows. I'm going to now export that. ClickHouse provides the ability to export essentially any query. So this is a simple example of that, where we are just taking the whole table. So we're selecting star from the table, putting it into an output file, and we're asking, and this is the important part, we're asking that the format be JSON each row. This means that each row is going to be formatted into a JSON object, and you're going to have new line after each object in the output, and that's the kind of input that we can easily ingest into Polaris. So I'll go ahead and run that. That'll generate an extract file, and I'll jump over into Polaris to show you how to ingest that. So in Polaris, so when you start and create your own Polaris account, this is the home screen that you're going to get to, right? Where you can have access to all the functions. Now, the base function that you need to do before you do anything else is add some data. So there's the convenient create a table and load data button over here that tells us to create a new table. So the only thing you need to start with is a name. So I'm going to just give that one a name. And then you can choose to either manually create your schema or directly start a batch ingestion. If you have a set of data that's in a JSON structure, it's very easy to do just start batch ingestion because it scans the data. So I'm going to show you that. Normally you could take the file that I just created. So you could go here, select files from the computer, get my JSON data and ingest it. I'm going to avoid that just because it takes a little time, and I've already uploaded the file. So I'm going to choose from uploaded files so I can show you the rest of the process. So I'm going to open that and go ahead and do the ingestion. So what this does is it scans the file. It scans a piece of the file, and it shows you which columns exist in the objects that it sees in the JSON structures, and then gives you a default mapping of which of these columns it considers to be dimensions and which ones it will consider to be metrics or measures that you're going to generate analytics on. So it's as easy as that, unless you want to change something, but for the most part, the default should behave well. And so you can just start the ingestion. I'm going to go ahead and start that ingestion. It takes a little time. So it takes a couple minutes. So in the interest of our time here, well, before I move to that, to actually show you, one thing to point out is this is doing a batch ingestion, right? This is taking a file and loading it up into this table. You can also use this push API endpoint. So what this gives you is a REST endpoint for this particular table that you can submit HTTP request to with data sets in the same format that we just saw in that JSON format. So this can allow this allows you to do direct streaming into our database as a service and into a specific table that you've created. We've got the blog post on that if you're interested in looking into that. I won't go further into that for now. I'll just finish here by demonstrating, now that we have some data, what can you do inside Polaris? So Polaris is an environment that integrates multiple things. It integrates Apache Druid. So the Druid database is behind it. This is what where the tables are and where the queries are running. And it integrates another Imply product, which is Imply Pivot, which provides a visualization layer. So in this visualization layer, I'm going to go build a data cube with it. It's really as simple as selecting one of the data sources, or you can create a query as the source for one of these cubes. And this by itself is an analytic environment that demonstrates the kind of real-time analytics that this database can do. Just to show you an example, we can bring in country, and that'll split, it generates a query to the database and is grouping by this dimension. You can change visualizations here. Maybe let's see, we do a tree map, and we may want maybe some other dimension to partition it on. So it's really as easy as adding more stuff, right? Oh, I didn't do that right. I'm not the expert in the visualization. Maybe I do time. Let's try that by city and time. So now we have a heat map over the time of the day and how it's different by city, right? And the activity of these particular events are different by city. So anyway, you see how it's an environment where you can do analytics and navigate the data very quickly. And this environment allows you to do significant scale in terms of data, and it uses the Apache Druid database behind it, so it has the speed and response times that we've been talking about. But this is sort of an easy route to get a proof of concept going on Polaris. So anyway, that's the end of my demo. I'll go back to Carl to finish this off. Carl, did we lose you some?
No, sorry.
That's fine.
Sorry, I was answering some questions. And
good.
Vitaly, I'm still working on your third question. So give me a minute and I'll get back to you. The question was from Vitaly: how do you know what size a Druid cluster should be? And so I was just about to paste in another guide for you there, Vitaly. I'm going to send you what I've got now, just because we're about to wrap up. But there's another guide I want to send you. So maybe you could send me an email, and I'd be happy to continue this conversation. So yes, top of the hour or bottom of the hour already. It goes so quickly. So thank you so much for joining us. Really should have more than half an hour for these sorts of things, but hopefully we got you enough information that you want to investigate further. So I would recommend visiting our website, looking at Polaris. You'll also get a follow-up email from us with a recording of this event, and also some other links of interest that you might have. And if you would rather just reach out to me or Sergio directly, maybe both of us at the same time, who knows? One of us will probably know something about what you're asking, I hope. There's our email addresses there. You're welcome to reach out. I was busy answering questions there during the demo, so if I didn't get to what you were asking, please let us know. It certainly wasn't because we don't want to, it's just we're running out of time. But thank you so much for joining us. I hope this was useful, and I hope that we'll see you around at another event.
Thank you.